Assalamualaikum, we are from Group 2. I am Nazira.
I am Sophia.
I am Isaac.
My name is Hisham.
We are doing experiment 5 refrigerant system.
Okay, next I will explain the introduction. So for the refrigeration cycle, heat are normally transferred. Heat are normally transferred from a higher temperature to the lowest. Therefore, this refrigerator is needed to reverse this process. So refrigeration consists of 4 main components, which are the condenser, compressor, evaporator, and the expansion valve. So these 4 components are very important for the refrigeration cycle, as each has a role to keep the process going. So the cycle starts when slightly superheated vapors enters the compressor from the evaporator, causing the increase in pressure and temperature. The hot vapor is now traveled to water-cooled condenser and heat is given up, causing the refrigerant to condense into liquid before getting through the expansion valve, thus resulting the decrease in pressure. Then, as it flows to the evaporator, there is a difference in temperature, causing the refrigerant to boil. When leaving the evaporator, it again becomes slightly superheated and returns to compressor. So, instrumentations are all provided at the instrument for the measurement of power input to the compressor, the gauge pressure, and the temperature, and all the required parts. So, this refrigeration cycle can be applied in the refrigerator and air conditioning in our daily use.
Next, I will explain about theoretical of the experiment. The method and the purpose have already been explained in introduction. The principle of refrigeration. Liquid absorb heat when changed from liquid to gas, and gases give off heat when changed from gas to liquid. And the vapor compression refrigeration cycle has 4 components, which is compressor, condenser, expansion valve, and evaporator. Okay, first, the refrigerant's low pressure gas will be flow into the compressor, and it will be compressed. As it go out from the compressor, it will go as a high pressure gas, and then the high pressure gas will be flow into condenser, where it will be condensed from gas into a liquid. And as it condenses, it will give off the heat to surrounding. And next, the high pressure liquid will be flow into the expansion valve, and the liquid will be restricted, and it will be lower its pressure. And then the low pressure of liquid will flow into the evaporator, and it will be evaporate from liquid to gas, and it will absorb heat as it evaporates. And finally, the low pressure of gas will flow back into the compressor, and the cycle will be repeated again. Next is the objective of the experiment. First is to determine the effect of condensing temperature and pressure on refrigeration rate and condenser heat output. And the second one is to determine the effect of evaporating temperature and pressure on refrigeration rate and evaporator heat output.
This goes to the evaporator, where it absorbs the heat and the refrigerator with the assistance of the evaporating liquid refrigerant. As the liquid evaporates, it decreases its temperature according to the decreasing in its pressure. Then it passes to the third component, which is the condenser. And the function of the condenser is to convert the refrigerant into the liquid form, reducing its temperature. And in the condenser, the heat flows out of the system to the environment. There are another components such as the barometer and the flow meter. Barometer measures the pressure inside the evaporator and the condenser, and the flow meter controls the flow rate of the fluid of the evaporator and the condenser respectively. And all the components is shown in this picture. And now for the operating procedure. After we all ensured the start up of the unit of the system by turning on the compressor and opening the water supply, we were ready to start our main experiment. And we started the main experiment by the first step, setting the evaporator water flow rate to 20 grams per second and allow the unit to run for about 5 minutes. Because of the flow rate of evaporator and the condenser are the main 2 parameters in the system, so we need to fix one of them so we can have a precise measurement, and we choose to fix the flow rate of evaporator to 20 gram per second and start with 30 gram per second for the flow rate of the condenser. After that, we recorded all the system parameters, including the temperature in and out, the pressure, and the power consumed by the compressor. The third step there was to reduce the condenser coiling water flow rate until the condenser pressure increases by approximately 10 kilonewton per square meter or 0.1 bar. As we decrease the flow rate of the condenser, the pressure of the condenser increases, allowing the unit to stabilize. And again, we recorded all the parameters to study the effect of the reducing of flow rate of the condenser flow rate and the other parameters such as temperature and the pressure in the system. And lastly, we repeated for increasing condenser pressure and decreasing the flow rate from 30 gram per second to 20 gram per second to the minimum rateable value on the condenser. Discussion and result will be discussed next.
Okay, next for our discussion. So this is the table of the result. As you can see, there's initial 1, 2, 3, 4, and 5, 5, and 6. So this is all the information that we have gathered in the experiment. So we have condenser, evaporator, condenser temperature, evaporator, compressor, and also we calculate the heat capacity of this experiment. So for this experiment, we will observe that the heat transfer rate for the condenser, based on the table, you can see when the water flow rate in condenser decreases, the heat transfer rate in condenser also decreases. So this is because the molecule of the water will be reduced, so pressure of the molecule will be decreased as the temperature also decreases. Thus, the heat transfer rate in condenser decreases. So next, this is actually a graph for this experiment. We have this is the saturated liquid line. Also, this one is saturated vapor line. So this one is the pressure line. This is high pressure and temperature line. This one is low pressure and temperature line. So this is pressure versus enthalpy. So in condenser, the refrigerant condenses at high pressure and temperature while rejecting energy to water flowing through the coil. This shows why at condenser, both temperature and pressure at higher value than at the evaporator. As we can see in this diagram below, in this diagram, saturation curve, this curve represent what state, vapor or liquid, and region, subcool, latent heat, and superheat, the refrigerant is in. It also splits into two sections at a saturation liquid line and evaporation vapor line. So the question is, what do the saturation liquid line and the saturated vapor line show us in the basic refrigeration cycle? These lines show us the refrigerant has reached the 100% point. So, for example, the saturated line, saturated liquid means the refrigerant has reached 100% liquid at point 4, this one. And there is no vapor. This is actually only liquid. So for the saturated vapor line, this line, mean refrigerant is 100% in vapor line, point 3, this one. So the saturated liquid stay in point 4, the intercept between high pressure line and saturation curve. So there are two pressure lines and two heat exchangers. The low pressure line is an evaporator, it absorbs heat, and the high pressure line is the condenser, it rejects heat. The first heat exchange that occurs in this basic refrigeration cycle is the evaporator. The air conditioner evaporator is located between point 6 and 1 in the basic refrigeration cycle diagram. The evaporator is a heat exchange that is responsible for absorbing heat from whatever place that needs to be cooled. For our discussions, it's indoor. So, do you remember thermodynamics second law? So this law states that heat always flows from a material at higher temperature to a material at lower temperature. Since the evaporator is low temperature than the air surrounding, it will absorb the surrounding heat until the refrigerant liquid inside the evaporator coil starts boiling as a result of absorbed heat. As the evaporator refrigerant has boiled completely to vapor, it's now saturated vapor at 0.7. So, as you can see, this is at 0.7. Some compressor cannot pump liquid. If it does pump liquid, it will demesh it. This is why we need the entire liquid refrigerant to boil at 0.7. After the entire liquid refrigerant turns to vapor and pass with 0.7, superheat occurs. Superheat is between 0.7 and 1. So, superheat is life insurance for the compressor. It makes sure the compressor does not pull in liquid refrigerant for the evaporator. So, as for the conclusion, the special chemicals called refrigerant are used as the substance that enables the process to function. The cycle involves the change of state, and the energy consumption and heat loss associated with these phase changes is the key to the process. So from the experiment, the heat transfer rate in condenser is decreasing as the pressure and the temperature are decreasing. Same goes for the heat transfer rate in the evaporator. It will decreasing when the temperature and pressure are decreasing. So that's all. Thank you.